Okay, students, in this video we are looking to solve radical equations. And before we get started, let's look at some basic knowledge that we will need. If I have the x squared is equal to, let's say, 25. To get x by itself, we would have to square root everything. So this will give me x is equal to plus or minus 5. Another way that I can look at this is if I have x squared is equal to 25, instead of square rooting everything, I can raise everything to the 1/2, which is essentially the same thing as square rooting everything. When I have an exponent raised to another exponent, such as in this case, I can simply multiply those two and I get x to the first, or simply x is equal to, well, 25 to the 1/2 is the same thing as the square root of 25, which in this case, it's going to be 5. So if we take another example, if I have x to the second is equal to 100. Again, to get x by itself, you want to square root both sides. X equals plus or minus 10. Well, what if we have an exponent that it's not a 2, such as, let's say, x to the third is equal to, let's say, 27. Well, just like before, I can take the, not the square root this time, but the cube root of both sides, the cube root. Or we can raise everything to the 1/3, and this would be x is equal to, the cube root of 27 is, well, 3, because 3 times 3 times 3 is 27. And we can apply this to any other exponent. It doesn't have to be a 2, doesn't have to be a 3, it could be anything else. So with this knowledge, let's look at one radical equation. So let's take this one, for example. It's hard to see. Let me make this a little bit bigger. All right, so what we have here is the square root of 3n plus 1 is equal to 5. So let's solve for this variable, and notice how everything is in the radical. So we know that this index here is a 2. So just like before, when I had to get rid of an exponent of 2, I would square root it. Well, now I'm going to do the opposite. I'm going to raise everything to the second degree. And this exponent of 2 will get rid of that square. So we get 3n plus 1 is equal to 25. Well, from here, I solve for n, minus 1, 3n is equal to 24. Divide by 3, n is equal to 8. All right, so remember that to undo an exponent, let's say an exponent of 2, I can square root it. To undo a square root, let's say it's the root of x equals, let's say it's 4. Okay, so this is a square root. I'm going to square it, and that's how I get rid of this square, or this square root. So I get x equals, in this case, 16. All right, so these are two different problems. Let's look at another example where we can apply this knowledge. So let's clear all this. And let's look at the square root of, let's do x minus 4, and then outside the radical symbol I have minus 1 is equal to 5. So here what we do is, before we touch anything in the square root symbol, I have to get rid of the negative 1, so I add 1 to both sides. I have the square root of x minus 4 is equal to 6. Now again here, let's get rid of that square root, and so the way we do that is by squaring both sides. So this becomes x minus 4 is equal to 36. We add 4 to both sides, and x is equal to 40. Okay, let's see, let's look at a couple more examples. Let's clear this again. One second, let's clear all this, and let's look at, let's see, we have 4 times, in parentheses we have 2x plus 6, close parentheses, to the 1/3 minus 9 is equal to 3. All right, we're gonna solve this. So before I get to the x, let's understand that this is one grouping. This is together. So I have to get rid of this negative 9. So I'm going to add 9 to both sides. And so that's gonna leave me with 4 times the sum of 2x and 6 to the 1/3 is equal to 12. Okay, I can't distribute the 4 into the 2x into the 6. I can't, because the 2x plus 6 is attached to the exponent of 1/3. And so what we're going to do is divide everything by 4, and we get 2x plus 6 to the 1/3 is equal to 3. From here, to get rid of this exponent of 1/3, there's a couple ways I can do this. Well, I think the easiest way is to raise everything to the 3rd. Everything, because remember that when we have an exponent raised to another exponent, I can simply just multiply those two. So I would get 2x plus 6 is equal to 3 to the 3rd. 3 times 3 times 3 is 27. Minus 6 minus 6. 2x is equal to 21. And so 2x equals 21. Divide everything by 2. X equals 21 over 2, or 10.5. 10.5. All right, so let's do another one that's a bit more complex. Let's clear all this. Okay, here we go. So let's look at the square root. The square root of x plus 21 is equal to 3 minus root of x. All right, so there's nothing I can move around, there's nothing I can combine, so right now we are going to raise everything to the 2nd degree, just because this is a 2 right here. All right, raise everything to the 2nd degree, and so this exponent will undo the square root. All right, so we get x plus 21 is equal to, well, over here we have 3 minus root of x times itself. So that's going to give us 9. So FOIL method, 9 minus 3 root x minus 3 root x plus the root of x squared. And we'll simplify this in a minute. So these two become negative 6 root x. This becomes, well, just x plus 9 is equal to x plus 21. Notice, let's combine like terms. So minus x, those go away. Those go away. I can do minus 9, and so that's going to give me 12 is equal to negative 6 root x, divide by negative 6, divide by negative 6, I get negative 2 equals the root of x. And remember, to get this x by itself, I can simply just raise everything to the second, and I will get x is equal to 4. And so that would be my answer. Most of the problems will be related to what we just did in this video. Please let me know if you have any questions. I hope this makes sense. If you need to rewind and play the video again, go ahead and do that. Have a great day.